There's a machine so far away from Earth that its signal takes almost an entire day to reach us. Not minutes, not hours, a full day, and somehow we're still talking to it, right now, as you're watching this. A spacecraft built in the 1970s, older than the internet, older than modern computers, is still alive, still listening, still answering, from billions of miles away. And the strangest part is, it was never supposed to last this long. It was never designed for decades of operation, never meant to survive this far into space, and yet it continues, silently moving away, while still holding on to a fragile connection with Earth. This is Voyager 1, the most distant object humanity has ever created. And we are still in contact with it. But that raises a question that almost doesn't make sense. How do you talk to something that far away with technology from nearly 50 years ago? How do you maintain a signal across distances so large they are difficult to even imagine? And what happens when it finally stops answering? When that connection disappears completely? When the last signal fades into silence and nothing comes back? To understand that, we have to go back to the beginning, 1977. The Cold War is still ongoing. Computers are massive, slow, and extremely limited. Memory is minimal. Processing power is weak, and everything must be carefully planned and optimized. And yet, NASA is preparing something incredibly ambitious, something that pushes far beyond what the technology of the time should realistically allow, something designed not just to explore, but to go farther than anything ever built. 2 spacecraft, Voyager 2 launches first, then Voyager 1. But despite the names, Voyager 1 is actually faster, placed on a trajectory designed to overtake its twin and escape at the solar system sooner. Every element of the mission is calculated with precision, every maneuver planned years in advance, because this is not just about reaching planets. It's about using them to go even farther, to gain speed, to break away completely. Because this mission wasn't just about exploration, it was about timing, a rare alignment of planets. Jupiter, Saturn, Uranus, Neptune, all positioned in a way that only happens once every 176 years. Miss that window, and the opportunity disappears for generations. There's no retry, no second attempt, no backup plan. Everything depends on this moment, happening exactly when expected. This alignment made something possible, a gravitational highway. Instead of carrying massive amounts of fuel, the spacecraft could use the gravity of planets to accelerate. Each flyby would act like a slingshot, pulling the spacecraft forward, increasing its velocity and redirecting its path. It's a transfer of energy, a way to steal momentum from entire planets, allowing a relatively small spacecraft to reach speeds and distances that would otherwise be impossible. Voyager 1 reached Jupiter in 1979, and what it saw changed our understanding of the solar system. Massive storms, swirling clouds, lightning stretching across enormous distances. A planet that never stops moving, never stabilizes, always shifting. It discovered faint rings around Jupiter, something scientists had not clearly predicted. And then something even more surprising: active volcanoes on Io, a moon that should have been frozen and inactive, was erupting constantly. That discovery changed everything. It showed that worlds beyond Earth were not dead, not frozen, but active, evolving, constantly reshaped by internal forces. The solar system suddenly felt more dynamic, more unpredictable, more alive than we'd ever imagined before. Then came Saturn in 1980. From a distance, it looks calm, almost perfect, with its iconic rings stretching across space. But up close, it's complex. The rings are made of countless fragments, ice and rock constantly colliding, breaking apart, reforming, shifting in a continuous cycle of motion. What appears smooth from afar is actually chaotic up close. Small moons move through those rings, shaping them, controlling their structure, preventing them from dispersing. Without those moons, the rings would slowly fade away. Even something that looks stable and eternal is actually fragile, maintained by constant interaction and delicate gravitational balance. And then there's Titan, a moon hidden beneath a thick orange atmosphere, completely opaque. A world with rivers, lakes, and weather systems, but made of methane instead of water. A place that mirrors Earth in structure, but not in composition. Familiar in shape, but alien in reality. But after that encounter, everything changes. Voyager 1 is redirected. Not toward another planet, not toward another mission objective, but upward, out of the solar system plane, into deep space. A one-way journey, no return, no next destination, just distance, increasing forever. Voyager 2 continues onward, exploring Uranus and Neptune, becoming the only spacecraft to ever visit them. But Voyager 1 leaves, and it never comes back. It continues outward, leaving behind everything it once observed, moving into regions where no spacecraft had ever gone before. Years pass, then decades. Voyager 1 keeps moving, faster than anything humanity has ever built. Every second, increasing the distance between itself and Earth, moving into a region we cannot directly observe, cannot reach, cannot fully understand, until it reaches something invisible, a boundary, the heliosphere, a vast bubble created by the sun, filled with charged particles streaming outward in all directions. It acts as a protective shield, separating the solar system from interstellar space, defining the region where the sun's influence still dominates. But even that boundary has an edge, and in 2012, Voyager 1 crosses it. It becomes the first human-made object to leave the sun's influence and enter interstellar space, a region shaped not by our star, but by the galaxy itself. A transition from one environment to another, from solar space to interstellar space. And yet, it keeps talking. This is where the story becomes almost impossible to comprehend. Because Voyager does not have advanced systems. It does not have modern communication technology. It relies on something simple, a radio, a dish antenna about 3.7 meters wide, transmitting signals with just 22 watts of power, about the same as a household light bulb. Now imagine trying to detect that signal from billions of miles away. A signal that spreads out, weakens, fades as it travels. By the time it reaches Earth, it is almost indistinguishable from noise, almost nothing, and yet we can still detect it because we built something enormous to listen, the Deep Space Network. Giant antennas in California, Spain, and Australia, positioned so that Earth's rotation always keeps one aligned with Voyager, ensuring continuous communication, even across immense distances. Each antenna is massive, over 70 meters wide, designed to capture signals so faint they should be impossible to detect. Even then, the signal arrives, weak, distorted, incomplete. Engineers must reconstruct it, filter it, amplify it, decode it, transforming a barely detectable signal into meaningful data. And then there's the delay. It takes about 22 hours for a signal to reach Voyager 1 and another 22 hours to return. Nearly 2 full days for a single exchange. Communication is slow, delayed, indirect. Commands are sent, and then there's nothing but waiting. Voyager is not controlled in real time. It is guided, carefully, deliberately, with patience. Every decision must account for delay, uncertainty, and risk. And after nearly 50 years, that process is becoming more difficult. Because Voyager is aging, its systems are degrading, its power is fading slowly but continuously. It does not use solar panels. There's not enough sunlight. Instead, it relies on nuclear power, converting heat from decaying plutonium into electricity. At launch, it produced over 400 watts. Today, less than half, and decreasing every year. Which means sacrifices. Systems must be turned off, one by one, permanently. The camera was shut down long ago, after capturing one final image. Earth as a tiny dot in the darkness. The pale blue dot. Since then, Voyager has never taken another photograph. Now only a few instruments remain active, measuring particles, magnetic fields, and the structure of interstellar space. Every watt matters. Every remaining function is carefully managed to extend the mission as long as possible, and still, it continues. But the connection is fragile, extremely fragile. A small error can break everything. In 2023, Voyager 2 drifted off by just 2 degrees. That was enough to lose contact completely. The signal missed Earth, silence. For a moment, it was gone. But then it corrected itself, realigned, and the signal returned. Voyager 1 experienced its own failure. It began sending corrupted data, signals that made no sense. Engineers had to diagnose the issue remotely across billions of miles, with massive delays. It took months, but they found the problem and restored communication. And that might be the most incredible part of this story. Not the distance, not the technology, the persistence of this connection. A conversation maintained across interstellar space for decades. But it will not last forever. Power continues to decline. Systems will continue shutting down. Eventually, there will not be enough energy left to transmit anything at all. NASA estimates that sometime in the 2030s, Voyager will go silent. And when it does, there will be no dramatic ending, no explosion, no final signal, just silence. One day, a signal will be expected, and it will not arrive. And that will be it, the end of the conversation. But not the end of Voyager, because it will continue moving, drifting through the galaxy for millions of years, silent and alone, carrying something with it. The golden record, a message from Earth. Sounds, music, languages, images, a snapshot of humanity, preserved on a disk, traveling through space. Not because we expect it to be found, but because we wanted to leave something behind. Proof that we existed, and that is the final reality. Voyager is no longer just a spacecraft. It is a message, a relic, a fragment of humanity moving through the darkness long after we are gone. And maybe, one day, something will find it and realize it wasn't alone. If you enjoyed exploring the mysteries of deep space, make sure to like the video and subscribe for more discoveries, because the universe is full of strange worlds, and we're only just beginning to find them.